Hello guys, I'm Jose Alvaro from ECE31. For today's vlog is about experiment for Boolean Algebra. The objective of this experiment is to check the theorems of Boolean Algebra in practical approach and to simplify the logic equations using theorems in Boolean Algebra. So watch and enjoy. Here are the materials that we will be using. For the first part of the experiment 4 is a double inversion circuit with a single input. Using 7404 inverter gate, we will be connecting the resistor to pin 4 and in series with the LED, then the ground. In pin 1 is the input A and connecting pin 2 to pin 3. The output of this circuit will be inverted twice. So, if the input is 1, the output is 0. Then, the output 0 will be inverted again to have an output of 1. If input is 0, the output will be off. If input is 1, the output will be on. And here are the results. For the part 2 of the experiment is the absorption theorem using AND/OR combinational circuit. Using 7408 AND gate and 7432 OR gate, we will be connecting a 360 ohm resistor to the third pin of the OR gate. Then, the LED connected in series, then the ground. On the first pin of the AND gate is the input B. Then, we will be connecting both second pins of the IC to each other and it will be the input A. Then, we connect the third pin of AND gate to the first pin of the OR gate. Then, the 7 pins of both ICs to the ground. Then, we connect the VCC to the power supply. For both inputs of 0, the output will be off. Then, we put the input B to 1, the output will be off. For inputs 1 and 0, the output will be on. If both inputs are 1, the output will be on. And here are the results. In this part of absorption theorem, we will be using OR and combinational circuit. Using 7432 OR gate, and 7408 AND gate, we will be connecting the resistor to the third pin of the IC. Then, the LED connected in series and followed by the ground. On the second pin of the OR gate is the input A. Then, we will be connecting the first input of both ICs to each other, and it will be the input B. Then, the third pin of the OR gate is connected to the second pin of the AND gate. And the VCC to the power supply. The 7 pins of both ICs is connected to the ground. For both inputs of 0, the output will be off. Then, we put the input B to 1, the output will be on. If the input is 1 and 0, the output will be off. If inputs are 1 and 1, the output will be on. And here are the results. For this part of the experiment, we will be using the 7432 OR gate and 7408 AND gate. The circuit have 3 inputs in it. We will be connecting the first and fourth pins of the OR gate, which will be our input C. Then, the second pin of the OR gate as input B. Then for the input A is the fifth pin of the OR gate. Then, we will be connecting the third pin of the OR gate to the first pin of the AND gate. The sixth pin of OR gate to the second pin of the AND gate. We place the 7 pins of both IC to the ground. The 360 ohm resistor is placed on the third pin of the AND gate with the LED in series and then the ground. Then the VCC to the source. If the 3 inputs are 0, the output will be off. If we put the input C to 1, the output will be on. If the inputs are 0, 1, and 0, the output will be off. If If the inputs are 0, 1, and 1, the output will be on. For inputs 1, 0, and 0, the output will be off. For inputs 1, 0, and 1, the output will be on. For inputs 1, 1, and 0, the output will be on. If all of the inputs are 1, the output will be on. And here are the results. For this part of the experiment, we're dealing with distributive law using AND gate and the OR gate. The circuit have 3 inputs in it. We will be connecting the resistor to the third pin of the OR gate. Then, the LED in series, followed by the ground. For input B, it is connected in the first pin of the AND gate. And for the input A, is connected at the second pin of the AND gate. Then, on the first pin of the OR gate is the input C. We will be connecting the third pin of the AND gate to the second pin of the OR gate. The VCC to the source, then the connections to the ground. Followed by the positive and negative terminals of the power supply. If the 3 inputs are 0, the output will be off. If we put the input C to 1, the output will be on. If the inputs are 0, 1, and 0, the output will be off. If the inputs are 0, 1, and 1, the output will be on. For inputs 1, 0, and 0, the output will be off. For inputs 1, 0, and 1, the output will be on. For inputs 1, 1, and 0, the output will be on. If all of the inputs are 1, the output will be on. And here are the results. For the summary of results, in the part 1 of the experiment, double inversion, we can see that the input 0 has an output of 0. It is such because we inverted the output twice. So if the input is 0, the output is 1. Then we invert it again and the output will be 0. Based on the results for the double inversion circuit, we can say that F is equals to A, which means that the inputs of A will be its output. So if the input is 0 and 1, the output will be 0 and 1 respectively. For the second part of the experiment, absorption theorem using AND or combinational circuit, we're using an AND gate and OR gate for this circuit. By deriving the Boolean equation based on the data that generates an output of 1, which are 1 and 0 and 1 and 1. The equation can be written as AB prime plus AB. And by simplifying this equation, F is equals to A, which means that the input of A will be our output, as we can see on the results. For the third part of the experiment is absorption theorem using OR and combinational circuit. By obtaining the inputs that would result in an output of 1, which are 0, 1, and 1, 1 inputs. These inputs can be written into Boolean equation as A prime B plus AB. Then, we simplify this equation, which will be shown. Then, F is equals to B. It means that the input of B would be our output. For example, if the input in B is 0, the output will be 0 as well. For the third part of the experiment is the distributive law. For this circuit, there are 5 with an 1 output in them. Then, we can put the inputs with outputs of 1 into a Boolean equation. By simplifying the equation using the basic theorems on Boolean algebra, we can come up with the simplest form of the equation, which is F is equals to A, B plus C. By using the simplified equation, we can substitute the different inputs of A, B, and C, then obtain the output that would result to 1. For example, the inputs for A and B are 0, and for C is 1. By substituting the values, 0 multiplied by 0 is 0, then plus C, which is 1. The output would be 1, or the LED would be on. For the distributive law demo 2, the outputs were the same with the first one. By making the inputs with an output of 1 into a Boolean equation, we can simplify the equation using Boolean algebra to come up with a simplified form of F is equals to AB plus C. Then, we substitute the values of the inputs A, B, and C to determine what inputs will generate an output of 1 and what inputs that will be 0.